Welcome everyone to Learning with Rev. In this video, we are going to be looking at the model.compile method in Keras. At the beginning here, we have our standard imports. We have the MNIST dataset being loaded and a basic convolutional net with our model being defined right here. This is taken directly from the Tensorflow API website, describing what the compile method does. So, start off, we'll just go over what each of these are. So, first option is our optimizer. Optimizer can be put in as two different ways. We could just do like RMS prop or atom, or we could define our optimizer equals tf.keras.optimizers.atom, and then whatever arguments that atom includes. For example, learning rate equals 0.001, and then in this case we'd put that optimizer right here. It's another way to write the optimizer. Next argument is the loss function. So here we are using categorical cross entropy as our loss, and we can use any loss that is in the form tf.keras.losses.binary cross entropy, categorical. All these other losses, mean absolute error, mean squared error, whatever one is applicable for this condition. So in our case, this is a classification problem, more than two classes, so we are going to be using categorical cross entropy. If there were just two classes, we could do binary cross entropy, and if we were doing regression, mean squared error or mean absolute error, one of those as well. And those can either be in this form here, or as I was showing before, the tf.keras.losses.categorical cross entropy, and there may be some arguments that you can place in there. Next one is our metrics. In this case, we are using accuracy metrics, and then within this list, we can add additional metrics, such as tf.metrics. We could use awk, accuracy, all these other metrics that we can, the mean squared error, and this will be reported to many different things. We can report it to TensorBoard, which is a visualizations package built in TensorFlow, or into our history variable when we train the model, and all that data can be read back and charted to see how well the model is training. So you can have many metrics that you'll be tracking within this list here. Loss weights are similar. Loss weights are optional. They are weights, so it will be a dictionary or a list specifying scalar coefficients to weight the loss contributions of different model outputs. So if we have many outputs to the model, we would weight each one to see how much they should weigh at the point when they are actually combined. So every multi-branch model, multi-output, all those branches actually come back together at one point. So that is a way to make sure they are weighted in an appropriate way that you need for your model. Weighted metrics, list of metrics to be evaluated or evaluated and weighted by sample weight or class weight during training and testing. So they'd be similar to our metrics here, but they are weighted. And then run eagerly. So if true, this model's logic will not be wrapped in TF function. You should always leave it to none or false, because it will execute much quicker because it will run as a tf.function. If run eagerly is equal to true, it does allow you to access the data within tensors that would normally not be able to be accessed. Let's say you're debugging it. And finally, steps per execution defaults to 1, and in that case, it is the number of batches to run during each TF function call. It can improve performance on TPUs or small models with large Python overheads, but I've never really played with that much. But with our default here, we can compile, and then we could train if we really wanted to. So thank you all for watching. I hope this explanation on how to use the compile method within TensorFlow models. Hope you learned something today. If you did, please share and like this video. If you have any questions, please leave it in the comment section below. Thank you all for watching, and I'll see you next time.